Perfect. I would say I'll start. Yeah, we are really happy to have you here, you both. We are pleased to meet you, and I welcome you officially, Miss Johanna Wendesten, and also Dr. Christian Rockstroh. Both speakers are working for Siemens. Dr. Rockstroh is a lead data scientist and is leading data science and IoT projects at Siemens. And Ms. Wendesten is a digital business developer who's connecting the front-running Nordic customers in the with the latest technology from Siemens in the IoT and platform space. Today, they are going to have a session about, is data essential for energy transition? And with no longer talking from my side, I would hand over to you both.
Hi, everyone.
Thank you.
Yeah, thanks for having us. We will make a 15-minute explain a little bit on energy transition, IoT, AI platforms. And then we are looking forward to your questions. Feel free to ask anything you want. We will answer to the best of our knowledge. Yeah, we're looking for an interactive session today. Yeah, all right. So, what is the energy transition all about? Just to give you a size of the challenge we are up against. So the investments into German electricity grids that are needed. Current forecast from E.ON is around 32 billion euros by 2030 and 110 billion euros by 2050. So massive amounts of investments will go into the energy grid. And so why is that? So imagine everybody would be driving e-cars. Imagine that all the heating you currently get from gas and coal you would get from electricity. And there is a nice KPI called primary energy, which basically compares coal, nuclear, gas, biomass, and solar energy together and asks, okay, how much total energy do we need, for example, in Germany? And what you can see is in order to have full clean energy, we would need 6 times the current number of biomass, solar, and wind capacity. And if you stick to only solar and wind, this will give you 13 times the amount. So 13 times the amount of wind and solar that is currently there. This is what you would need to build in order to supply that energy. So it's a big issue. Yeah? And we're not only talking about the grid. So the energy grid is really about the power generating units that push the energy over the power transmission to municipalities and your local grid. So this is one part of what we call the Internet of Energy, which connects different industries, buildings, and different players together. Yeah, and those players have very different challenges, from the big oil and gas, petrochemicals, to hospitals, and they all are concerned with making that energy transition possible. And Johanna will share a bit on what her experiences with the challenges we see in the Nordics at the moment.
Exactly. So looking into 3 of the main stakeholders, namely the utilities, owners of the grid, the buildings, and the industries, we see that looking at the grid, first of all, they're facing challenges when it comes to the stability of the load balance as the amount of renewable energy and e-mobility introduced into the energy mix increases. Second of all, there's a large need to replace a big part of the aging infrastructure, as actually more than 80% of the Nordic transmission grid were built before 1980. And when replacing this step by step, the utilities are also expanding the transmission capacity to meet the current as well as the future demands. Moving on to the buildings, a number that's I think it's a bit small in the Nordics, but I think it's interesting from a worldwide perspective, is that the buildings actually make out 41% of the energy consumption worldwide, and are therefore a critical part of being able to reduce our CO2 emissions. But in order to achieve this, we also need ways of monitoring, for example, the comfort and the temperature within the buildings, so that we still find them good places to live and be inside of. And the same goes for the industries, that we need to reduce the amount of energy that they are using. But in order to do that in a viable way, we need to ensure that we still keep our output stability. And thirdly, it's really interesting that with new technology, we can actually use both buildings and the industries as an active player in the energy field, as it can become both renewable producers as well as storage players, allowing for new income sources, as well as supporting the challenges that the energy transition poses on the infrastructure. So moving on to then how can IoT specifically and data then support these challenges? Well, for example, then using temperature sensors within the rooms of the buildings, you can then control the heating much more efficient. And use cases similar to that explains why the Market Institute see that IoT in the energy market will almost double until 2025. And looking at another example of how we can actually use the data then is looking at wind turbines, because in order to get paid for power produced, you need to put a bid in at an energy market about 24 hours before it's actually being produced. This is sometimes challenging when it comes to the renewable sources, as it's not really sure how much the wind turbine will be able to produce tomorrow. But Google has recently done a machine learning project where they used input such as weather data, as well as technical input from the wind turbines, to predict much more accurately how much they will be able to produce within the next 36 hours, meaning that they were able to make much more accurate bids, thus contributing with more wind power to the energy mix while making more money from it. But what do we need to think about when we introduce more IoT sensors and technology into the energy space then?
Yeah, so I think you could imagine that all the transformers in the energy grid and all the motors and compressors in big industry companies are actually connected. So there are a lot of sensors out there, but that's actually not the case. So a lot of the data we would actually need to solve some of these issues about grid stability in the lower end of the grid, about optimizing energy consumption, we don't have that data. Yeah, and that's why grid operators and industries are now putting more and more IoT devices into their systems so that they can actually measure how much is the motor consuming, how much energy is produced by solar and wind. Yeah, and when you see that amount of new sensors and IoT devices in, then every sensor becomes a potential cyber target. So security is absolutely key when we talk about innovation, yeah, because we can't just pull all the sensor data in a big cloud and then run our AI algorithms on it and improve. Yeah, we need to have that in a secure place. Yeah, and so you can imagine that this whole internet of energy is under attack by terrorists, organized crime, but also employees. Yeah, even though, for example, we had this big blackout in Ukraine, where 220,000 people were actually without energy for quite a long time, and this all started with a spear phishing attack on one employee. So training your employees, making your technology much hardened, complying to regulations, ensuring that the systems are secure is key to actually start innovating. Yeah, so security is the absolute basis for innovation in that Internet of Energy. Yeah, and that's why what we do with our platforms, like our IoT platform MindSphere, is making sure that everything is secure end to end. So the devices and the sensors. They use strong authentication mechanisms, secure communication protocols, and we make sure that those cryptographic keys that are in the devices are secured properly. Yeah? And you need these types of IoT platforms to actually start innovating, because we see there are a lot of entrepreneurial people out there that try to make a difference with new hardware, with intelligent devices, or new algorithms that try to reduce energy consumption, being better at forecasting. But what you need is to have an actual platform where you can do this innovation on. And you have seen this challenge, and we think the speed of innovation that we needs to be much, much higher. So we need people to innovate on new AI algorithms, to have more federated learning approaches where we learn from many, many players in that Internet of Energy together. And that's why we think the platforms need to reduce the entry hurdles for innovators so that we can make IoT and AI very accessible and secure, so that people with ideas can then run on this. And this is actually what Johanna and folks in the Nordics have done with university.
Yeah, exactly. So, like just discussed here, is that the interesting things really happen when we can work together and we get a large amount of data accessible than we have today. And this is really a big challenge for the different stakeholders, I think worldwide, but that I really see up in the Nordics. So what we did over the summer was working together with actually Norwegian net DSO, so distribution system officer, that are in charge of a part of the Norwegian grid, where they had started to just buy a few temperature sensors to be able to monitor the status of the substations much better. And they also wish to combine this data with a few signals from our substations that contains Siemens transformer and Siemens devices. So what we then did for 8 weeks was to onboard this data onto the MindSphere platform, and with people with an energy background really knows very well, okay, what can we use this data for, but might not really be cybersecurity experts or really connectivity experts. And that's really where I think that MindSphere and the whole lowering the bar for being able to upload the data in a secure way, making it accessible, is really, really key. That we were in just a few weeks' time able to really onboard the data and then visualize it using a low-code tool called Mendix, to really enable the people spending the time on where it really matters, rather than just spending time on understanding all of the cybersecurity standards, all of the communication protocols, and instead spending more time on really developing the use cases and see, okay, what trends do we see here? How can we combine the temperature data with the load data, for example, to see which substations we could load more or we need to be more restrictive with because they're really at the maximum capacity. So yeah, this is one example of how we're really trying to get the technology out there. This is the picture of the island. It's kind of cool. It's a really, really small Norwegian island that they're using as a test bed. They have a few batteries, windmills, onshore fish production is a really big thing in Norway, actually, a way of being more efficient when it comes to food production as well. But then really seeing, okay, how can we get as much data as possible within 8 weeks and see what we can do with it. And yeah, they were really happy with the outcome, and we have continued working together since as well, just because having the data, getting the data available as quickly and as secure as possible is really key for this market segment, where you want to put the investments where they really can really give you a good value, and not just spending all your time in the IoT space, but rather quite quickly coming up to the AI and machine learning part of it all.
Yeah, and I think as that we want to lower the hurdles, and that's why we also have for both Mendix and MindSphere kind of free packages where we say, all right, for Mendix, for example, we have the university program where your professors can apply for, and then your teams and your departments can actually work for free in the classroom. You can use that technology. You have all the documentation, certifications you can do. And yeah, I think it's a very cool way to start your journey when you're not a full engineer. Yeah, even if you have a smart idea, you can just start. And same goes for MindSphere Start for free. That gives you easy access to get started with IoT in a fast and secure manner. So we have templates where you can just plug in a Raspberry Pi or your iPhone and other devices. So it's really fast to get into the first stage of IoT. Yeah? And of course, down the road, we have production-ready apps that are coded with Mendix. So it's not just for prototyping, but we have large customers that actually use Mendix with production code that are handling massive amounts of data. Yeah, and I think this is what gets you on that journey. Yeah. All right.
Perfect. So, as I understand, that's the end of the presentation.
Yeah.
So, thank you both for presenting, and it was really refreshing to see a real project and also a project where you work together with a university, and also to see the significant outcomes of them. So there are a lot of questions, because like the energy topic is a pretty interesting topic, and also if you think about the term of in terms of sustainability. So the first question by Fabian Habermehl is, it's no real question, but you can give your opinion about it. Let's say it like that.
Okay.
I do wonder if SMR nuclear reactors might help with the stability of the grid. What do you think about that?
Well, it's...
Should I?
I don't think I really... Yeah, you go for it.
Yeah, I think so. Overall, this is, I think, as Siemens, I would not speculate where we see new energy sources are coming from. I think what we always need is to reduce the carbon footprint overall. Yeah, I think we see new advancements. I think on every front, SMR could be something that will be part of the mix. I think this will be part where we need to have that, where we have to have the public discourse about the benefits of having clean energy, but still you have the problems with the waste management of nuclear. And I think we should have a public discourse about those risk benefit ratios. And then, yeah, I think different countries have a different assessment of SMRs and other technologies. Yeah, and I think as long as we have that discussion, and then we will decide as yeah.
Yeah, if, for example, if we look at Germany, you can see that like the topic of nuclear energy is like condemned, and if you look at other countries, they see the nuclear energy as like the only sustainable, like more or less sustainable solution for stopping like things like the climate change or slowing down the climate change. So
absolutely,
yeah,
and I think that's a decision to make. I think I think US will maybe see things differently if they have large SMR producers, depending on if fusion will still be 30 years away. I think there's also new advancements in wind turbines that are put into inner cities. So there are a lot more kind of vertical wind turbines that also could help us gather more wind in the inner cities. I think we we are up for a very interesting decade and 2 decades. And I think the more we try to find new ways to create energy in a sustainable way, I think the better.
Yeah. Looking forward to the future of the energy sector. So the next question would be, should IoT security be mandated with a certain standard for security, seeing how often devices that are part of the IoT lack security features of a like fully fledged desktop or laptop, for example?
Yeah. So I can only speak for the energy sector, and the energy sector is extremely regulated when you try to put certain IoT sensors in the grid. So, for example, our current customers, they want, for example, no control ability from the cloud or from IoT sensors. So this stays very local and protected. And you have a lot of regulations you need to, for example, there's called compliance and called kritis, which means standards for critical infrastructure, where people try to manage that risk and have regulations for this. I don't know where the IoT regulation in general will go. Yeah, because you're absolutely right. We have many security problems with that. But in terms of the critical infrastructure, I think the European Union takes quite some efforts to protect the grids from malicious IoT devices.
Yeah, I think that, like in general, cybersecurity is playing a big role or a main role in today's time, but it will also play a way bigger role in future. In like any sector, I guess that's not only the energy sector or the IoT devices that are affected by that, but like in general, everything that will come up in future.
Yeah.
So let's have a last question on fusion technology. So Tim Zickenroth is saying, we currently see exciting news in the industry more often, and these have usually been achieved with the help of AI and machine learning. Do you have trust in future breakthroughs and its potential to solve many of today's energy problems? And are there hurdles for the grid similar if this energy source would be viable in the future, in the sense of necessitating the same investment in the grid as you described?
So I think one of the key questions is, are you running a decentralized or a centralized grid? So we have a lot of decentralized energy sources here in Germany, and we're pushing more decentralization. So you need to have, so if you want to have more decentralization, you need to make the lower end of the grid. So where your municipalities are, where your cities are, you need to make this much, much stronger, especially if you have more e-mobility. So e-mobility will push that need for a larger things. But if you stay centralized, I think then you are again in a discussion of having larger big plants or not so big plants. But as we see, there will be a mix. And to just to share a bit on grid stability, we're not only talking about the load in the grid, but also the frequency stability. So this means you need to keep the 50 hertz of that frequency stable. So you need to have plants that can ramp up down very, very fast. And that's why gas is so important at the moment for having that renewable energy, because once you lack the renewable energy, you need to ramp up very fast. And that's also a reason why people are saying we need smaller nuclear plants or smaller plants in general, because those are the ones you can ramp up faster and down. If you have a large nuclear plant and you have a drop in solar or wind, it's very hard to ramp those up and down. And I think that's why people are discussing smaller, more decentralized power plants.
Yeah. Seems incredibly complex. Like to find the right solution there.
Yeah, it's an interesting topic. So if you want to always feel free to ask us on LinkedIn, follow us on our websites, and there will be more news to come, I think, in the next months and years on this topic from Siemens.
Definitely, this journey has just only started.
Yeah.
Thank you so much. Thank you really much for being here, for having this session with us together. And I think that I can also thank in the name of Tech Academy. We are very happy to have you at our tech conference, and we are looking forward for future endeavors and future cooperations, hopefully.
Yeah. Thanks for the organization. Great job. And have fun with the remaining sessions. Yeah.
Have a great weekend and see you. Bye.
Thank you. Bye.